Good afternoon, everyone, and thank you for joining our webinar on AFDDs, Dispelling the Myths with Eaton. We're just gonna give it a few minutes to let more people join, then we will start. Perfect. For those who just joined us, welcome to our webinar with Eaton on AFDDs, Dispelling the Myths. My name is Wee-Em Melki. I'm the Marketing Coordinator at Rexel, along with Jamie McCall, our Marketing Manager at Rexel. Our guest speaker from Eaton is Trystan Bevan, who will be introducing himself shortly. Please note that this is a recorded webinar and will be available to watch on demand on our Rexel website. This webinar is CPD accredited and certificates will be sent directly from CPD, which can take up to 4 to 5 weeks. If you have any questions throughout the webinar, please feel free to pop them in the Q&A box and we will answer them at the very end. Now passing over to Trystan from Eaton.
Hi, good afternoon, everyone. Thank you to Rexel for arranging this event on AFDDs, Dispelling the Myths. Just a little bit about myself. I'm the UK Field Marketing Manager for the power distribution at Eaton. I've been with the organisation now 14 years and done numerous roles in that time in both sales leadership and marketing. Just as we start, let me give you a little bit of an introduction on Eaton themselves. Who is Eaton? We're an intelligent power management company. We employ around 85,000 people doing business in more than 175 countries worldwide, with an annual sales turnover last year of 19 billion. Every day around the world, people depend on technology, transportation, energy and infrastructure to live and work. At Eaton, we're dedicated to improving the quality of life and the environment with sustainable power management technologies that are more reliable, efficient and safe. With the rapid growth in electrification and energy transition driven by climate change and explosive growth in connectivity, we're well positioned to solve some of the world's toughest electrical, hydraulic and mechanical power management challenges, because that's what really matters and we're here to make it work. There's lots of content around our power management on eaton.com, and if you can go on there for lots of further details. Just to give you an idea of the portfolio of products that Eaton produce, in the electrical sector we produce products and solutions for control and automation systems. We provide engineering services. We produce harsh and hazardous environmental solutions. We have a life safety and security division, which includes emergency lighting and fire. I myself am from the power distribution and circuit protection segment. We also do things like uninterruptible power supplies, backup power, and now energy storage solutions. We also have an industrial sector which covers off things like aerospace, automotive, e-mobility, infrastructure, hydraulic, and truck. So let's discuss some AFDDs and dispelling myths. Just to recap on traditional circuit protection, which I think is important to start with, just to understand the reasons for it and why we're looking at AFDDs. Previous schemes in traditional circuit protection, from the most basic installation of live parts, to the fault protection, automatic disconnections of power and faults. These aren't replaced by AFDDs. AFDDs are a complementary measure on top of them. In the last 20 years, additional protection has been recommended and mandated, the likes of MCBs or RCDs, and then additional protection with residual current protection on devices as well. The reasons for these and the typical faults we're protecting with these devices are overcurrent, creating excess heat, short circuit currents, always caused due to the lack of insulation, mechanical damage or fluid ingress, or you have things like earth faults, and that's again down to things like aging of insulation materials, mechanical stress, direct contact with live parts, and indirect contact with live parts. These are all the current types of protection faults, and the typical protections provided depends on the device that's on the system. MCBs, as of the late 80s, became the standard, and with those you're provided that short circuit and overcurrent protection and a very basic level of fire protection. RCDs in the form of RCCBs will provide that earth fault current protection, and these have been mandated now for over 30 to 40 years and used on the incoming circuits. And then later on, as technologies develop, the RCBO, which now offers the highest level of protection at the current levels of protection, and that provides you with that earth fault circuit overcurrent and that increased level of fire protection and shock protection. So what is an arc fault? It's probably important that we start here just to understand why there is a need for an AFDD. An arc fault is a micro lightning that can lead to large fires and initiated in cables and wires. Fixed installations and cables or direct connections to devices or devices connected via sockets. The typical arc fault remains undetected on our current and commonly used circuit breakers. So what are the typical faults where protection is provided? Most common fault for arc faults is serials arc. These are often below the nominal current. Current still flows and not a short circuit, but a high resistance fault that generates heat and is not high energy. Arc fault never gets smaller. Parallel arcs, most common with nominal current, so there's no tripping again at the MCB. And then we have the arc faults between the live and earth, and this potentially can cause the RCD to trip, although also potentially doesn't. 25% of electrical fires, 25% of all fires are caused electrically in Europe every year. That's 4,000 deaths, 70,000 injuries, and 126 billion euros of fire damage. Arc faults are a key factor. They can remain hidden and can be both sudden or created over months and undetected. Electrical fires ignite suddenly and cause a serious threat. These arc faults are generally not detected by the current protection offered. Numerous causes of arc faults, as you can see here: crushed wires, damaged insulation, age of the insulation, things like drills going through cables are all known causes for arc faults. An AFDD should be capable of seeing these even over an extension lead or a device, unless there is a transformer. So this is part of the reason why an AFDD would be a recommended device. I'd like to provide you with a real example of something. My colleague will go unnamed on this, but we have here an RCD consumer unit connected downstream to an RCD socket. This was then plugged into his EV car overnight. The charger plug has become damaged, and when he returned in the morning, the RCD had not tripped, nor had the socket. However, the car was fully charged, but the pin had melted away and disconnected itself due to the arc. An AFDD would have detected this. The RCD did not. And this is part of the reason that we're looking at AFDDs today, and why the standards are changing, is to provide that additional level of enhanced protection. As you can see here from this diagram, it really shows you that current protections still offer a potential for risk caused by arc. This is where the AFDD provides that additional protection and reduces the risk. The idea of the AFDD is to complement the current protection levels offered by basic insulation, fault protection, and the additional protection of RCDs. Based on if we go through the regulations and the recommendations in a little bit more detail now, you'll see that the UK and Ireland have had regulations around AFD recommendations since 2018 and the launch of the 18th edition. In BS7671 Amendment 2, this becomes a requirement in specific applications. However, if you look at other countries in Europe now, in Ireland, we see the 5th edition published in 2020 now makes recommendations to expect to see these becoming requirements at some point. But across Europe, in different EU countries, we are now seeing recommendations for these devices across specific applications, and it seems to be increasing safety and reduce the risk of electrical fires. And as we see those develop, we'll keep everyone updated on those. Part of the regulatory landscape that we have, Eaton's provided a number of guides and blogs on the standards in the UK, and those are available at eaton.com. But a number of high-profile fires now in the UK have brought fire safety into the forefront of everyone's mind. If we think about Grenfell Tower fire inquiry, now that found multiple things went wrong here: raw materials, fire doors, audits of building, lack of responsibility and ownership for building. And although the source of the fire was unknown, what is known that there was an electrical fault. And questions were asked why existing devices did not switch off and prevent the fire. Safety is becoming more high profile here, and a key driver when designing systems to a higher degree, and things like the Hackett report have made that very clear. In this slide, we're showing a summary of some of the details and analysis of fire in England between April 17 and March 18, carried out by the UK government. There is a UK website link on the bottom of this presentation here, and we can provide that for you if you'd like to look at this in a bit more further detail. You'll see that statistics, that there are 2 points. First is the electrical distribution systems and applications today represent the highest second cause of ignition of fires, and the second highest fatality rate. However, in the latter, this is clearly influenced by Grenfell during this period when the statistics were produced. So we can see there is a major opportunity to still improve safety associated electrical systems and products to prevent fire. Secondly, on the right-hand side of the slide, you will see that the likelihood of a fatality in a fire is not uniform across all age groups or genders. We can see statistically that men can be nearly 3 times greater risk than women of dying in fires, and that someone over the age of 80 is 3 times more likely to die in a fire than the general population. What we have here under the scope of the Building a Safer Future is in 2012 to 2018 rates of fire involving fatalities or casualties. The primary scope of the Building Safer Futures was multiple occupancy and residential buildings over 18 metres. But when you look across the building types, then apartments, care homes, shelter homes are all high risk. Also, when you take a look at it, higher education becomes a risk as well. And although it does state education there, we're looking at things like boarding schools and student accommodation, and all those have been put at higher risk. the Hackett report does make recommendations on this, although it falls short of covering all other high risk, and recommendations should equally apply to these. So as it stands at the moment, and as the current 18th edition before Amendment 2 is instigated, there currently is suggested applications for AFDD appliance, AFDDs. These include sleeping in premises, including multiple occupancy dwellings, student accommodation and hotels. These are all currently suggested. Buildings dependent on with particular characteristics, storage of highly flammable materials, wood workshops, stores, etc. And buildings that are made of combustible materials such as wood are also suggested to have AFDDs located in them. Also locations where you've got irreplaceable objects, so the potential for much more damage in higher risk areas like museums, libraries and art galleries. As BS7671 Amendment 2 comes into place, those suggestions then change to requirements for certain premises. These premises are things like sleeping accommodation, multiple occupancy dwellings, student accommodation, which, as you saw by that previous report, was a very high risk area, and then things like high risk residential housing. Now, these are buildings over that 18-meter height, and they will now have that required status. Also, homes of multiple occupancy. This doesn't negate from the fact that BS7671 still has the recommendation for the previous buildings as discussed. Let's discuss a bit about the technology involved here. So a device, what is an AFDD? It's essentially a device that's designed to mitigate the arc fault by disconnecting the circuit when the arc is detected. It can be a standalone device, or it can be combined with a number of technologies, be that MCB or RCBO. We call those in Eaton AFDD+. But all of these that you can see here are devices that complement. So the AFDD complements the RCDs for fault protection and additional protection. There's multitude of different types of AFDDs on the market at the moment. You have your standalone AFDD, an add-on unit to an existing, an integrated MCB AFDD, or like the ones produced by Eaton, an RCBO integrated AFDD or AFDD+. Just to give you a typical example of what that looks like, this is a AFDD with RCD and MCB. This provides you with the all-in-one device that provides that earth fault current, short circuit and overcurrent, and serial and parallel arc fault detection. And that is in one specific unit. And when designing systems, the typical applications you need to consider are things around breaking capacity, current carrying capacity. Typically, AFDDs are 6 to 40 amp and come in versions from 6 kA to 10 kA available all today. How does an AFDD work? It's important to understand this because there are a number of things that do come up when we talk about AFDDs. An AFDD essentially, when an arc fault occurs, has a unique and readable characteristic. High frequency noise within the fault current and a breakdown of the fault current close to zero crossing of the driving voltage. These characteristics are used to detect arc faults and at the same time prevent nuisance tripping. A question that's commonly asked is about nuisance tripping here. And just to give you a bit of understanding of what we are trying to avoid with nuisance tripping, in certain electrical circuits, there are numerous causes for nominal naturally occurring arcs. Things like switches, contactors and relays, motors including those portable devices, and more commonly these days as well, power line communication. To avoid this, appropriate testing is taken in to you and used to avoid potential issues in both tripping and masking. And you can see here by the diagrams there exactly what we're talking about between the difference between a naturally occurring arc and something that is an actual arc fault. So let's get through some of these myths and misunderstandings. I've heard lots of talk around the fact that AFDDs are untested and unproven. I mean, these products have now been around in the marketplace for a number of years. They are designed and continue to be developed to make sure that they prevent nuisance tripping and work effectively. We are able to demonstrate that on one of our test devices, which we're happy to come and show you. AFDDs trip only on true arc faults and not nuisance tripping, and designed specifically around that. You can test an AFDD with the test button on itself. Our Eaton units themselves have their own self-test as well, but there is no need to go to test MCBs. The same is true of testing an AFDD. The AFDDs are only required on power circuits as well. There's no need for AFDDs on lighting circuits, as these are deemed lower risk. And AFDDs are part of a requirement in BS7671 Amendment 2 on specific applications and suggested applications. For others, they are not a requirement on every circuit. It's also important, I think, to understand a bit about the regulations and how they've developed since 2018. So the initial drafting was completed in 2020 at the beginning of the year. That was then published for public comment across the year then until the end of 2020. Work then commenced on taking that consideration and editing the documentation until the publication this year in the 28th of March. And now the Amendment 2 becomes effective as of 1st of October. So those requirements for specific applications will then come in place for AFDDs, and obviously the recommendations will remain for the rest. So in summary, why we use AFDDs. Over the last 10 years, there has been a continued monitoring in the US of electrical fires. In 2011, a Fire Protection Association reported that out of 47,000 fires, 50% could have been stopped if an AFDD device was in place. In America, they've been using AFDDs since 1990, and now 48 states use these as a mandated requirement in homes as of 2018. As we see this, there's no studies carried out on the effectiveness of AFDDs at the moment, but it's likely we'll see continued development of higher requirements for AFDDs in higher risk buildings to prevent fires, and we'll see that across the EU as well. Just a reminder here that you can view a number of our webinars on our website at eaton.com Virtual Knowledge Hub. You can also visit there to get some more information on BS7671 Amendment 2. We do a number of on-demand webinars there, also some guides on BS7671 Amendment 2. So if you'd like any further information, you could go online and view it there. And I know that this presentation today was being recorded for you. So we'll keep you updated with further webinars of anything specific. You will get an accreditation for this CPD and a follow-up email for this. But what I'm going to do now is pass over and see if there's any questions for the presentation slides that I discussed today. And please feel free to also go to my LinkedIn page if you've got any questions and you haven't had a chance to ask them today. I'm more than happy to take questions there as well.
Thank you, Trystan. That was a brilliant and insightful presentation. Really appreciate it. We've got a couple of questions, and I'll just ask if anyone attending does want to ask a question, fill it out in the chat box, in the question box now, and we'll try and get through as many as we can. We currently have 3 at the moment, so I'll start. First question from Lee. He asks, do offices areas below flats above 18 meters require AFDDs?
I will go away and double check on that. It's only power circuits on AFDDs in residential accommodation, but I will double check on the standards on that. I wouldn't like to say yes or no now, but I can certainly come back to him on that one.
Yeah, brilliant. So we'll follow up with you on that one, Lee. Then a question from Shahid. He asks, have Eaton developed a single module version similar to the Electrium or recently launched Hager versions?
I can tell you that watch this space. In the next couple of months, you will see further announcements on a number of products that we are developing within the range, including a single 18mm AFD device and some additional extension AFDD boards for the commercial applications where we're looking at student accommodation or other buildings of that type.
Exciting. James asks, are AFDD/RCBO devices being developed into one single pole device?
Yes, they are. That is something obviously that we are currently working on, and you will hear an announcement shortly from us.
And James also asks, will they be required on domestic properties?
The current recommendation would be that if it was a home of multiple occupancy, then yes, it would be. At the moment, as the standards go, there isn't that requirement. However, as we see this evolution of these standards, and as we see with things like the requirements in America, which seem to be about 10 years ahead of us when it comes to an arc fault detection device, I would say that at the moment, no, there's not a requirement. However, for additional protection on those residential homes, it's definitely something of an upsell.
Yeah, brilliant, thank you. Question from Will, is there any scope to bring the AFDD into a single module unit as other brands have? I think we've already answered that one, haven't we?
Yeah, no, again, we are currently, well, we will shortly be updating some new products in the portfolio. This includes a single pole device and some additional distribution boards to accommodate some of the larger AFDDs.
Yeah. Question from Peter. How differently should we approach fault finding in an AFDD protected circuit?
Well, I suppose it depends on the actual AFDD device. If you look at the Eaton's AFDD device, it's quite easy to identify what fault has been caused using the device itself with the LED indicators. What I would say is, depending on the device you're using, if it's an Eaton one, for instance, that you are able to identify what was the fault reason from that device, so that you can go about identifying what the fault was.
Okay. A couple of questions here might be related. I'll just do them one at a time though. Does the use of AFDD devices affect the method of wiring the circuit, i.e. radial/ring circuits?
No, it doesn't. They're specifically designed in the single pole device, for instance, so that you don't have to change the configuration.
And also, will they be required to retrofit as remedial work following fixed wire testing?
I do not believe there is anything in the standard. And again, I would like to come back to that person with an answer on that before making a definitive. I don't believe there is a requirement at the moment to retrofit. However, you know, I'm sure we'll see how the regulations change moving forward, but not to my knowledge at the moment. But I would like to go back away and confirm that before.
We'll come back to you with more clarity on that, James. Question from Eric: why is there such a wide price range in the market for these devices?
Generally, it's probably because of the functionality and features of the devices. So as we talked about in the presentation, an AFDD can come in multiple formats. It can be that all-in-one device, which I showed you on the screen. So it's an MCB, an RCBO, and an RCD and an AFDD, or it can be a standalone unit, which then requires the additional devices. And I imagine the pricing would be down to its functionality in that way. So an all-in-one device, for instance, is more likely to cost more than a standalone AFD device, which requires then an additional MCB.
Yeah, makes sense. We've got 4 more questions, so I'll allow 5 more, and then we'll take the other ones offline. This one from David. Just a reminder, I guess, did you mention that lighting circuits are low risk and therefore do not require AFDDs in high risk accommodation? Just checking, as we are designing sleeping accommodation.
So that is the guidance on BS7671, that lighting circuits are classed as low risk, and it's only the power circuits that require that AFD.
Brilliant. Question from Bruce. I think you've answered this one, but we'll go anyway. How do we know what type of fault has tripped the protection?
Again, depending on the device, so I can only comment on the Eaton devices. The actual unit itself will give indication via the LEDs of what's actually caused the fault. So if it's an arc fault or if it's something else.
Yeah. And then final question from Gareth. Hi, similar to the emission of surge protection devices, do we need to document acceptance that the AFDD are emitted? My thinking is the regs state recommended.
I believe they state recommended, but again, when it comes to the regulation stuff, what I will do is I will go away and double check for you before answering that as a certainty.
Yeah, no problem. And again, Gareth, we will follow up with you on that via email. William, you got anything to add?
Nothing to add. I think it was a brilliant presentation. Thank you, Trystan. And thank you everyone for your questions.
Yeah, thanks everyone for attending the webinar today. As William mentioned at the start, it will be available to watch on demand on the Rexel website. As Trystan mentioned, there's a knowledge hub for Eaton where you can get loads more information as well. And we'll be doing more webinars in the future, so look out for those. Thank you everyone for joining, and thanks again to Trystan for answering all the questions and his brilliant presentation. Thanks all. Have a good bank holiday.
Pleasure.